2.2 percentiles.
What's a master?
There are two formulas that we're going to be learning in this lesson. The formulas are related to each other. They're not exactly the same. And there's a couple of small little twists with the formulas that we just have to make sure that we remember. This idea of percentiles can almost, rest assured, it will appear as a short answer multiple choice in the final exam and probably one step in a long answer. So we're done now with the one lesson review that we did yesterday, mean, median, mode, and we're going to talk about something new today, percentiles. Okay, before we get to that, it's human nature to rank stuff. It's just part of who we are as humans to compare yourself with someone else. Say you're taller, you're shorter, you're smarter, you're whatever. So it is very much human nature to compare yourself. And it's very much human nature to compare yourself in large groups as well. You know, I've got the highest mark, I was the fastest in this race, whatever the case is. Go ahead. Thanks. The concern, however, is that if you have a lot of data, or if the data seems to be different, then it's harder to compare things. For example, let's say you wanted to compare to see if, how tall in fact are you? So you think you're a really tall person, how tall are you? You can compare within this class, you can compare within the grade, you can compare within the school, you can compare within the region, within the province, within the country, within the world, right? You can compare that. You can compare it between genders, you can compare it between ages. You can compare just all people who have brown hair. Am I the tallest person with people who have brown hair? So when you start looking at that idea that you can compare things across different groups of people, well, those different groups will be different. If you want to say the tallest person in this class, well, that means you're the tallest person in all classes. Well, that doesn't make any sense. You have to check the people in the other classes. So in order to compare across different groups, it's not as easy just to look at a number and compare with another one. We have to try to convert those two numbers. What I mean by that is, maybe here's a better example. Okay. So what we want to do, so here's a better example. Let's say on your last math test, you got a 32 out of 36. Okay. And you've got a friend in Miss Gervais' class. And in Miss Gervais' class, the last test that they had, their test was out of 48. Well, and they got I don't know, 31. So you got actually, let's make a better mark. Let's say they got a 44 to 48 and you got a 32 out of 36. Well, how do you compare that? You can't because the numbers are different, right? But if you want to compare that, you would need to turn it into percent. Because if you can turn it into percent, now you're working with the same idea. You're working with the same base of numbers. And that's what we have here. When we talk about percentiles, it's not a percentage, but it's really related to that. We're looking at stuff out of 100. A percentile is used to rank data. Rank means to compare with something else. Some of the things we're going to look at is going to be out of 100. That's what the whole percent means, out of 100. The higher the percentile, the better. Accordingly, the lower the percentile, the worse. That's not a word. Okay, so we're going to compare stuff by turning it into a quote-unquote percentile, which is kind of like a percentage, not exactly. And by doing that, the bigger the number, the better. So if you get like a 99 percentile, that's better than a 1 percentile. So here's the formula to do this. To calculate percentile. New formula, make sure you write this down correctly. It looks long, it may look a little complicated, but it's not once you start using it. You're going to need space for this. Percentile equals number of values less than plus the number of values equal divided by 2, all divided by total number of values times 100. Okay, write it down first. Make sure you write it down correctly. It's a formula that I could easily write it down in a short form. Like I could say, okay, it's going to be z plus p divided by 2 divided by t all times 100. We could say all that, but then we'd have to talk about, well, what does z mean, and what does p mean, what does t mean? So instead of doing that, I'm just giving you in words instead. So write it down again. It says percentile equals, big bracket, number of values less than, this is the top of the fraction, plus a mini fraction within the fraction. That mini fraction is number of values equal to divided by 2. That's the mini fraction on the top. The whole thing is being divided by the total number of values. Close the bracket times 100 on the outside. A couple of things that you literally have just done wrong. Some of you forgot to write the divide by 2. Make sure you have that. Some of you have a subtraction sign. Make sure you have an addition. Some of you just put the division sign over here. You said this divided by the total number of values. You don't have that part. It's not. So make sure your formula is written down correctly. If it's not, then everything that we're going to do is going to be wrong, so make sure it's correct. So now that we have this, let's do some examples on how to actually make this work. It looks pretty nasty. It's a bit of a beast of a formula. But again, the only reason why it looks that bad is because instead of giving you little variables here, I decided to write it in the word, so it looks longer, it looks worse than it actually is. Okay, example. Wait a second. We're not done. There's more to this formula.
No.
And the extra little bit of this formula that we have to try to remember, and that a lot of us will forget, it's not the actual formula, it's when you calculate the formula, you get an answer. All year long, I've been telling you, when you get an answer, just leave it. 3 decimal places, you're good. Done. Leave it, leave it, leave it, leave it, leave it. Not this. I'm going to put a little note here. Always round up. Whatever you get as an answer here with a decimal, round it up. Not down. Up. Even if it's a 0.1, you round it up. Always round it up. We can talk more about that later if we get a chance. Now let's get to our first example. Here's the formula. Always round the answer up. Okay, let's say the following is a list of quiz marks out of 14. We could go on, and I can give you long situations here, which you'll end up seeing in homework and maybe quiz and test questions. It's fine. But for the purposes of our examples and our lessons, I'm just going to get right to the meat. So here's a bunch of numbers for a quiz. So let's say we've got 3, we've got 5, 7, 8, 9, 10, 10, and 13. And 14. Do a couple questions. Question A. What is the percentile? Spell it. Percentile. Someone who received a mark of 9. What is the percentile of someone who received a mark of 9? So if you're the person with a 9, care about the actual mark. Yes, you got a 9 out of 14 and whatever it is, 60 whatever percent. That's not what I care about. I'm asking the percentile rank. Where do you rank in this class? Now, you could say, oh yeah, you're right in the middle. You're the person who got the middle mark. Oh, if you're in the middle, you're 50%. No, that's actually not what we're talking about. So you're looking for the percentile of this person. To do that, we're going to use that formula, the percentile formula. Maybe I can squeeze it in here. I'm not going to rewrite the formula all over again. We never do that. But I do need to see the first line where you input your numbers, and then you can give me your answer afterwards. So definitely something to put down in your notes for sure, and definitely a formula to put down in your memory. So let's use that formula. To use that formula, we're looking for the person, the percentile rank of the person who got a 9. So that formula says first, bracket, the number of values less than. How many values are less than 9? 1, 2, 3, 4. It's 4. We don't have to argue there. 1, 2, 3, 4 numbers are less than 9. 4. Plus, how many numbers are equal to 9? How many 9s do you actually see? One of them. So the number of values equal to would be 1, divided by 2. That's always a division of 2, not division of 3, not division of 4. The formula itself says divide by 2. The whole thing is being divided by the total number of values. 4, 5, 6, 7, 8, 9. So we have a total of 9 numbers here. 9 times 100. All right, let's calculate that. First time we're doing a new calculation with a new formula. Take it in steps. Ideally, if you could type all that in one line, then great. If you need to do this in steps, that's fine too. 4 plus 1/2 divided by 9 times 100, and then round it up.
Actually, wait, I'm going to see if I get the same answer.
As always, I mean, if you have your own way of calculating this, if you want to do this in steps, that's okay. Somebody will just turn this into 4.5 immediately, and then 4.5 divided by 9 times 100. Great, you can do that too.
Sure enough. What's the answer? Yeah, that's what I thought. You just do 4 plus 1 and then divided by 2 and then divided by 9.
Good. I would stay away from stuff like this. Don't do 4 plus 1, get an answer, then divide by 2, get an answer, then divide by 9, get an answer, then times 100, get an answer.
Well, it was all on the same line.
It depends on the calculator, right? Like anything else we do this year, it depends on the calculator and how you type it in. When you do all this, 4 plus 1/2 divided by 9 times 100, you get 50 exactly. There's no rounding there. Even though the formula says round up, there is no rounding because there's no decimal involved. If it's a whole number, you leave it. You're done. That is your percentile rank. Hold on, sorry? You shouldn't need to.
Oh, never mind.
If you're looking for the fraction button in your calculator, look for the button that says probably ABC like this, or it could say AB like this. That's maybe your fraction button. Who's not sure about that? Max? Show me the front of your calculator. Show me your calculator.
I did the fraction like 1 over 2.
So if you're having a problem, maybe you want to do this backwards. Do 1 divided by 2 plus 4 divided by 9. So go this way.
What the bracket is again?
Depending on this person.
I just got 3 different answers.
That's so weird.
So let me put the next question up, and then I'll come around.
You need to get a new calculator.
B.
No, it's that.
You need to get a new
I really
calculator.
want that one.
That one's way better.
Yeah, because C.
What is the percentile?
Yes, mine.
Your calculator?
Of 10. Okay, take a second, give that a try. Come around if you're having a problem. Okay, so your calculator is actually the best. And do bracket and do fraction.
I'm a genius.
And go to the top of fraction.
Yeah, I did
4
I did brackets 4 plus 1 over 2 brackets.
plus. Hit the fraction button again. 1 over 2. You can literally type it in exactly what you see. First does the bottom, put a 9, close the bracket. Pressure down the side. Times 100.
Oh, wait, number of values equals 82.
Okay, but it's not attempted in the first time, and that's the one that gave me the right answer.
Damn it.
What did I do? I think I closed the bracket.
No.
I know I did 4.
4 plus 1 divided by 2 equals, and you divide by 9. Mackenzie?
Which 10 do we use? The first one or the second one?
Okay, so let's try this. Some of you have a chance to finish this, some of you didn't.
He said good question.
It's the same thing.
Okay, let's have a look.
It would be the same thing.
Next question, percentile of 10.
No.
So naturally,
No, because they have less numbers.
gentlemen at the back, I know you're still working on this, but maybe just have a quick look.
Values less.
Percentile of 10, we clearly have 2 10s. So the question arises, which 10 do you use? You don't choose a 10, you're using a 10. Whether you choose that 10, or that 10, or both 10s is irrelevant. Because it's just the same 10 anyway. So when you do your formula says the number of values that are less than. Okay, so let's count. 1, 2, 3, 4, 5. Great. We have 5 numbers that are less than 10. So in your formula, there are 5 numbers less than 10. Plus, the number of values that are equal to it. So how many 10s do you see? We have 2 of them. So the top number of that mini fraction is 2. Divided by 2. Divided by the entire thing, the total number of values, which is 9. Close the bracket, times 100. This second example was different because we have multiple 10s. In the first example, we only had 1 9. So when you have more than one thing, then that's the number that's changing on the top. The other difference is, in that question over there, we got 50 on the dot, we were done. Here we don't get an exact number. So here we do have to worry about that rounding. So take a second now, type that in, just like we were talking about earlier. 5 plus 2 over 2.
Hold on.
Divided by 9 times 100. So when you do that, you'll get 66.66 repeated. It goes on forever, which is wrong.
Oh, it's what?
67.
Let's listen to me, please.
Oh.
Nathan, hold on. Okay. So 66.666 is wrong. If you write your answer as 66.666 or 667 or anything, it is wrong. The percentile formula tells us we have to round it up. We didn't have to do it there because there was no decimal. We already got a whole number. So here, round it up to 67. Always round it up. Never round it down. Questions before we continue?
It's like 64. It's like 66.
66.4, you round it up to 67. Always round it up. Doesn't make a difference what that decimal is, always round it up. Okay. That's the first half of the lesson. The second half is a new formula again. So this formula is used to find the percentile. But if you're already given the percentile and you want to work backwards to get the actual number, then we essentially are going to take that formula and rearrange it. When you rearrange it, you end up with this. To work backwards and find a number based on percentile, we use this formula, position. This one's slightly easier. Percentile divided by 100 times the total number of values. So second formula is mu make sure you write it down correctly. It is easier to deal with than the other one was. Because we don't have that little mini fraction inside that we have to work out. So it says position is equal to percentile divided by 100 times the total number of values. So this is what to do if you're given the percentile and you actually have to go backwards and find the number. But just like earlier in the percentile formula, there was something to add on. There's a little bit to add on here. Now let's think about this. In the percentile formula, we had to always round up. So think about that. If we're going backwards, always round down. The other thing is, we're not getting the actual answer when we do this formula. We're getting directions as to where to find the answer. So we're not saying that we get a number from this. We get some position. The position is telling us where to find the answer. So where to find the answer, which means we're going to have to do a little bit of work afterwards. Let's do an example. Consider the following test marks. Test marks out of 36. 16, 19, 20, 24, 28, 30, 35. I'll read them out again. 16, 19, 20, 24, 28, 30, 30, and 35. You should have 8 numbers in your list. Just like before the previous example, we'll do 2 examples here. Find the value that has a percentile of 93. Find the value that has a percentile of 93. We have 2 formulas here that are related to each other. One's to find the percentile going forward, one's to find the position going backwards. It's quite common, especially at the beginning, to think that those 2 formulas either mean the same thing, or you're not sure which one to use. The easiest way to figure that out is what information do you have? Here, we're told that the percentile is 93. So if you're told the percentile is 93, you're not going to use the percentile formula because you already know it. So if you know the percentile, then that means you're using the other formula, the position formula. I'm not going to write that down, but we have it over there. Let's just go right into it. Position equals percentile divided by 100 times the total number of values. Percentile is 93 divided by 100 times the total number of values, which we said earlier was 8. We have 8 numbers here. So we do 93 as a percentile divided by 100 times 8. That one is, I think we can all do that. You don't have to worry about brackets or anything else. When you do that, you get 7.44, which is wrong. You don't get 7.44. Because in our position formula, we're rounding it down. So when we round it down, we get 7. That's not the answer.
It's the 7th number.
It's the 7th. Sorry. Oh, no, sorry. Let's, hold on. I took it for granted that I did that correctly. Let's just make sure. 93 divided by 100 times 8. You get 70. Yeah, you get 7.44. Round 7.44 down, you get 7. So if that was 7.1, you get 7. If that was 7.9, round it down, you still get 7. That's still not the answer. This is telling you where to find the answer. This is the position. So this is telling you that the seventh number in our list is the actual answer. So let's go back and look at the seventh number. 1, 2, 3, 4, 5, 6, 7. That's the answer, 30. So the difference between this formula, or the common mistake here, is not rounding it down. The other common mistake is just thinking that's the actual answer. That's not the answer. The answer is telling you in the list where to look. Let's actually stop it right there, because I think we've probably